and my project is the effects of white noises on your sleep. The question that this project will be answering is which white noise provides the most uninterrupted sleep? Over 50% of the world has trouble sleeping. In this experiment, the question being answered is which white noise provides better sleep? The white noises used in this experiment are a bedroom fan, thunderstorm noises, and chirping crickets. The outcome hypothesized in this experiment is that the bedroom fan will provide the best sleep. To complete this experiment, the participant will complete their nightly routine from Sunday to Thursday 2 times. Then the participant will turn off the light at 9 p.m. and fall asleep. The white noise that provided the best sleep was the thunderstorm sounds, so the hypothesis was incorrect. The way that this experiment will help society is that the people in the 50% that have trouble sleeping could look at this experiment and see which white noise helped the participants sleep the best and see if it helps them sleep the best as well. The outcome hypothesized for this experiment is that the bedroom fan will provide the best sleep. These are my variables. My independent variable is the white noises used. My dependent variable is my duration of sleep. I didn't have a control or constants. My constants are the same person being tested, same watch. The testing was done at night for 30 consecutive weekdays, and the testing was done throughout the night. Over 50% of the world has trouble sleeping. This experiment will figure out which white noise might help you sleep the best. There are many different white noises, but the ones used in this experiment are a fan, thunderstorm sounds, and chirping crickets. Poor sleep is linked to higher body weight. Short sleep duration is linked to higher risk for obesity. The effect of sleep on weight gain is believed to be caused by hormones and motivation to exercise. Poor sleepers have a risk of heart disease and stroke. 15 different studies have found out that people who get less sleep from 7 to 8 hours per night had a higher risk of heart disease or stroke. While white noise is a better noise for some sleepers, white noise masks sudden noise changes that could interrupt your sleep. White noise doesn't help all sleepers, just some. For others, white noise completely disrupts sleep, allowing all noises to be heard. Sleep trackers monitor duration, quality, and phases of sleep. Some are also able to track your movement. How they detect these things are with accelerometers or small motion detectors. This data is then used to create a format to estimate your sleep time and quality of sleep. These are my materials. My Garmin VivoFit watch, which is my sleep tracker, my white noise fan, which was my fan, and my Alexa, which provided the other two noises, which was the thunderstorm and the crickets. These are my pictures. My procedure is I put a sleep monitoring watch on your dominant hand 2 hours before bed. Climb into bed at 8:40 p.m. after turning off top light and turning on side lamp. Read your book of choice from 8:40 p.m. to 9 p.m. Turn off the side lamp and fall asleep to your white noise. Sleep until the alarm goes off at 6:30 a.m. Repeat steps 1 through 5 using the fan for white noise for 10 consecutive weekdays. Repeat steps 1 through 5 using thunderstorm white noise for 10 consecutive weekdays, and repeat steps 1 through 5 using crickets white noise for 10 consecutive weekdays. This is my first data table. This is my second data table, which is for thunderstorms, and my third data table, which is for crickets chirping. This is my data table averages. The light sleep average for fan was 4 hours and 71 minutes. For thunderstorm, it was 3 hours and 25, and for crickets, it was 3 hours and 84 minutes. For deep sleep average for fan was 4 hours and a half. For thunderstorm, it was 5 hours and 56 minutes, and for crickets, it was 4 hours and 96. For awake average for fan was 10 minutes. For thunderstorm was about 8 minutes, and for crickets, it was about 5 minutes. This is my first graph for fan, my second graph for thunderstorm, my third graph for cricket sounds, and my averages, which is the same data as in my data table. As seen in the graphs and charts shown above, the thunderstorm noises provided the best sleep. The thunderstorm sounds provided the longest duration of deep sleep, the second lowest amount of awake time, and the lowest time for light sleep. Although looking at the three types of sounds, thunderstorm sounds were only slightly better than the other two options. The hypothesis for this experiment was that the fan would produce the best sleep. To conduct this experiment, I climbed in my bed at 8:40 p.m. every night and read my book. I fell asleep at 9 p.m. while my watch tracked my sleep. I did this for 10 consecutive weekdays with 2 weeks for each sound. At the end of my experiment, the thunderstorm sounds proved the best sleep. Problems that occurred during this experiment was one night our fire alarms went off, and another I unexpectedly woke up with a bloody nose. Both of these events caused disruption in my sleep, causing me to redo the night. If I were to do this experiment again, I would try different white noises and maybe a different sleep tracker. Also, I would possibly try some sleep spray that I saw on TV and see if that works better than my thunderstorm sounds, which provided the best sleep. This is my works cited.